Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome to my product development series. We are back working on the shredder. I'm supposed to do another video today, but I didn't have a chance to. I think I'm going to push it back to next week. So let's go ahead and take a look at some of the stuff that we need to do. So we've updated the model. I didn't have a chance. I had to go get a physical, tetanus shot, and blood work done. Then I went to a car show. I have a car show every day this weekend. So I was not able to go and get go and finish that video or put together my new side piece to fix the old one. Basically, what happened was I did go to the shop and try to get some 3.5-inch plate and make it 6.5 inches, but they only have 4-inch plate, which I already own. So I'm gonna have to get some I might have to go to like a San Jose State shop or something and cut that, or maybe do something along those lines. Was that my cat? Sorry, cat's meowing like crazy. So I'm gonna have to do that first before I could weld this thing together and show you guys the finished product. Hopefully or maybe go over to my ex-boss's machine shop and use the manual mill to do that. Yeah. So here we have the motor set up, where this is located, and now we have the new assembly. So let's go ahead and do that. So let's drop the motor assembly in there. I mean the shredder assembly. So what I'm going to do is I'm going to save that there. And I'm going to do this. And this. I'm going to file save as after I go back into the motor. Give me 1 second. Let me turn on the fan. Sorry, it's starting to get hot in here. It's probably why my cat's complaining. And let me open up my window. And there we go. Okay. So now we do drill mount, and we have the 1/2-inch spade handle drill. So what we're gonna do, oops. And now that we got that, we're gonna save that. Good. Boom, drop that in. Oops. Let's just mount it. Okay. Actually, before we do that, That's fine. That's okay too. Let's just rotate it. There we go. Okay, so now what we're going to do, let's hide the joints. Now I want to adjust this so that we have this guy actually sticking out instead of this 10 inches. So what we're going to do is we're going to stick this out, the portion that it actually sticks out. For that, I need my, here's my tape measure. So yeah, so I'm gonna say it's about, let's say it's about 3/4 of an inch stick out of the 10 inches. Okay. Now, another thing I'm thinking is I'm thinking that this is going to have to go up to the front and go across so that we could put the secondary gear somewhere in here. Okay, so another thing is that this guy actually has this piece on here. So what I want to do is let's actually accurately model this. Okay. So basically what we have, 0.788, which we already have. And that piece protrudes out, so we have a little shelf here, it looks like. That piece protrudes out 0.060. This is above the seal or the gear or whatever this is. Then what we have is we have a rectangle. .662. Okay. Now that guy. 0.215, I'm going to say. Then take out the left-hand thread screw. Which is 0.620. But first I need to know 0.620 and 0.490. 0.620. Insize holes 0.194. And 0.830 deep. Okay. Okay. So let's see what he says. You want to create thread. $10.24. Interesting. Okay. So there you go. Yeah. Okay. Okay, so basically what I want to do wait. $3.19. There we go. And it's a very small number. One, two, three, four. It's like 3/10 of an inch. Is it forward or backward? we can do that. Yeah, I'll go with that. Okay, so now we are in line. Alright, so basically now what we need to do is, but we have an issue, is that this guy, we want this guy to be over there. Actually, okay, screw that then. There we go. All right. Yeah, it's too far forward now. 0.156 back. There we go. Oops. 5/10. That's okay. Okay, so Okay. All right. So, what we're gonna do I think the contact point is this point right here, or this point around here or something. I believe. Yeah, I think it's 2.5. Okay. So let's say 2.5. Okay. Why does this thing look super sideways to me? Okay. Three and a quarter. 3.25 inches. So obviously this is 3 inches. So basically we're gonna have a gear here and a gear somewhere over here. Okay. So now obviously we want 600 divided by 30. We're gonna step down 20 times. Now technically this gear is 3 inches. Oops. This gear is 3 inches. Alright. So basically what that means is that we have to go through 2 gears to get to this gear because of how small this gear has to be. Now, how small can this gear actually be? So this is 788. Let's say. Let's say we have 1/4 inch teeth on it. 1/4 inch long teeth. How long are these teeth? See, they're about 1/2 inch long. So I'm okay with 1/4 inch. All right. I mean, the teeth could be longer, so the teeth could be 1/2 inch, but it looks like its contact area is about 2/3 that, so they're going to be a little bit longer. But let's say this is the contact area here. So from this contact area, 2.635. Okay, so let's say that is the case. So that means that so 2.635 and let's use this 2.5. So this is actually bigger. 2.635 divided by 1.288. It's only 2 times. So what that means is we might need a couple gears just to step down. So we're going to need from here. Okay, so from here, let's say we're rotating at 100 RPM here. And obviously we're talking about contact area here. Contact area, contact area. So .045. Now we're at 293. And now we're going to go back up because this is bigger than this gear. So every time this turns, this is going to go further. So that's not good. So what that means is that now this one's got to be smaller and then another one smaller. So that's 2, but 2 is too small. So let's say that this was down to a, let's see if we can fit another one in there. Or basically this one's got to be smaller. What if we had 0.125? But then this one's still going to step up, right? Oops. That one always be tangent. 2.76. 2.76 divided by 1.038. It's 2.6. So what I'm thinking is that we could do a 10 and a 2. So maybe we can move this closer onto this side. So what I'm saying is that we get a 10 and a 2. So that means, let's say that this is 0.25, 1.288, that means that that has to be 12 inches. That's not going to work. So let's split the difference. 20 squared is 4.47, but then that's still too big. This thing is just going to have to be barely bigger than this thing. It's going to have a tiny little gear. Or what we're going to have to do is we're going to have to do some sort of chain, because the only other thing you could do is do a chain, but that's basically what you see here. And so if we do 4 here, then that's too big. Because if we do 2.5, basically means it needs to be 1/8 of an inch. So what if we did a bigger? Okay. 1/4 inch is way too small. So what if we did whatever this is? This is 4 inches, right? A little bit under 4 inches, 3.9. So okay, so it's a little closer to 1/4 inch, but 1/4 inch is tiny. So what if we did 60? We can't drop it down that far. So divided by 60 is 10. Okay. Square root of that. 3.16. But then that's still too big here. And basically what that means is that from here to here it needs to be 3.16 times bigger, and from here to here it also needs to be 1.65 times bigger. So what I'm going to have to do is off screen, I'm going to have to think about this over the weekend and devise a formula and kind of talk about this and how we're going to do it. So one of the couple ideas, number one is we do a belt driven or a chain driven, where it goes onto these, and then you have big gear sprockets that go out here and then they attach. Now if it was going to go from there all the way out, then let's say that this is a 1 inch gear here, then it's going to have to be a 20 inch gear basically. Now unless I have some sort of dual layer gear here, which is like an inch, 2 inches. So I'll cut it in half, so now you're at 300, and 2.50 divided by 2 divided by 2.5 divided by 2 is equal to 1.25 divided by 300. It's 240. Still not down far enough. That's just a 2.5 times reduction. Okay, so we might have to make a gear train here and then go to this one, or do some sort of chain something. A tiny little gear. I mean, again, the thing that I would like to do is I would like to get it to fit around this square piece here. But maybe what I could do is I could make a custom where it's a custom shaft where it goes here and then reduces and then kind of goes around this one. But even then, this guy here is pretty small to begin with. That's already 1/2 inch. So even if we contact out here, let's say we make this thing super small. Yeah, like 0.65. Still. So we're probably going to have to do a gear train. So we might have to do like 1, 2, maybe like two plus gears. Gear here, and gear here. That might get us to where we need to go. I'll think about it and I'll devise something to calculate it, and we will get back to it on my next video, which I have to pick up. I'll probably do that like Sunday or so. Alright, thank you guys for watching, and I'll see you guys next video. Take it easy.